Welcome to Pavithra Laptop Care. See, we have received a board. It's a Dell 5400 touchscreen laptop. Okay, for this we don't have schematic. Actually, it's a LA. See the model number. For that LAG892P. We don't have any schematic or board view, but we can manage using LAG891 schematic. Okay, there will be a logic actually. See, in this video just I will show you how to find out the fault in logic level. Actually the gate logic circuits will be there, no? So how it will happen? Actually it's a little bit complicated because it has used multiple MOSFETs, N channels and P channel MOSFET also used because of protection. Actually it will protect the main charging IC. Actually see, the main charging IC is 9538H. It's a really dangerous IC because a small issue will happen in this, so it won't run the battery supply, it won't give the battery supply, then board won't turn on. Okay, now the situation is board won't turn on. In that case, how you will search the logic? Just I will show you the fault, where exactly the fault in logic circuits. Okay, the logic circuits is in a sense it's a P channel MOSFET as used here. So in that P channel MOSFET the gate logic will be there. No, that circuit has some issues that I will show you how to find out. Okay, see, the main thing is supply. Here is a 19 path supply. First it will come to this. First I will tell you the logic how it will work, then I will give the supply and I will show you what exactly the voltage is. See, here PQ9 is the first MOSFET. Okay, after this what voltage will come? That voltage only goes to this particular charging IC input as a input. Okay, so now the main thing is 19 volts comes to here source of this P channel MOSFET, but the gate logic should be voltage divider. Always P MOSFET, once it comes, so gate voltage, gate logic should be voltage divider logic. See, the voltage divider means the second MOSFET should be, the destination should be ground. That ground, by using the logic circuits, that ground will happen. Okay, so how it happened? See, here is the MOSFET 1, 2, 3 is the source. Directly it comes from here to here. Just in a beep I will show you. Multimeter. See, the source will come. Okay, after that the gate, according to this gate only, here full voltage has to come or less voltage has to come, will decide. But the main thing is this has multiple logic circuit. What is that? The gate is connected to this 6 leg PQ8 is there, PQ10 actually. This is a 6 leg MOSFET, dual N channel MOSFET. Okay, so it has connected for protection IC. This is actually protection IC. So using this only the 19 path will release. According to the logic, actually it's a pin number 2. If receives the voltage, then almost all except 3 all will be the ground. Okay, that is the logic here. If it receives pin number 2 receives voltage. Okay, that is the logic in this. After that it connected to one more P channel MOSFET. That is here actually. Here, right. Here is the P channel on metal. I will remove this fan. Here PQ6 also is there, and this one, it's a PQ11. It is connected to PQ11 logic. Actually it's a P channel MOSFET. The main supply is connected to the source, and the gate is the logic, that logic which I told you, no, from that logic it will give the supply. So here the drain is connected to the gate of this particular MOSFET which I told you, no, this MOSFET. Okay, that is the logic here, that protection circuit logic. After that here gate logic will happen. That last MOSFET, which one? Actually it's a PR on mat. What is that logic? Here it's a PQ6 which I told you, no, that one is connected to the gate logic. See, this is the PQ6. Here is the drain, here is the what is that? Here is the gate and source. Okay, the main thing is source is ground. Is it correct? Yes, this is source, and here is the gate. Gate, if receives any voltage, then only this logic will happen here to here. Okay, so then your voltage divider will happen and you will get the appropriate voltage to the gate, and this particular MOSFET will be turned on. Okay, so now what I will do, I will give the supply and just I will show you the supply of the gate voltage is coming or not, present or not. Just a minute. Here, see, I am going to connect it. Connect it. So now 19 voltage. Check the multimeter. Here is the PL, the main supply coil. First it's coming 19.5 volts. Okay, after that source which I showed you now, the source is 19.5. What about gate? See, gate also 19.5, means here voltage divider is not happening. Why it's not happening? See, many of the technician won't check that logics. Directly they will short this MOSFET or something they will do directly from here to here, source to drain they will short and they will get the voltages. But actually it's a wrong method. What are the protection method, the logic circuits of the protection? First we need to check one by one. See, I'm disconnect the okay, gate we already checked, right? Okay, now we need to check the MOSFET one by one, if any due to that over voltage any protection happened or not. Okay, the main thing is which I told you, the gate supply is connected to this 6-leg logic. Okay, now this one has short or not, that first we need to check. Here to here, any pin, number 1 no, here no, number 2 no. Okay, 1 minute. Okay, here actually here pin number 1 and 4 are ground, that's why it's giving beep. Just a minute, once again I'll check. Pin number 1 and 4 are the ground, correct. This one is correct. Other than that the logic is good. Pin number 2, 3 there is no ground, 6, 5 also no ground. Okay, only pin number 4 and pin number 1 are the ground. This one is okay, but what voltage we are getting, that we will check. What I am telling, it's a pin number 2, if it has voltage then all will be ground, and pin number 3 also should be voltage should be there. That's happening or not, I will give the supply and we will check. Giving the supply. See here, one by one I am checking. Pin number 1 anyway it's a ground. Okay, it's a voltage. See the pin number 2, it receives 3.3 volts. Okay, it means if pin number 2 is present, then pin number, what is that? Pin number 3 also should be voltage and remaining all should be ground. See pin number 3. Yes, it has 16.3 volts. But what about pin number 4? Already ground. Ground. 6, there is no voltage. 5, there is no voltage. Once again 5. Carefully we need to check, it's a no voltage. Okay, only 2 pins we have voltages. Okay, if voltage is good, then what about P channel? That we need to check. P channel PQ11, which I told you now. Please check the schematic. While explaining the schematic, you will get bored. So that's why I am not explaining the schematic. Directly practical session I am showing you. See, ground PQ11. Okay, here is the gate, source, drain. So now source separate and drain separate, because gate should be voltages, right? Gate has some voltage, that pin number 3 in the 6-leg MOSFET. Now see, the gate has voltages. So what is that? 17 point something it has voltage. What about drain? Drain is connected to the gate logic. High low MOSFET is there, no? Sorry. R1 source and destination. Just a minute. Voltage divider middle point it has connected to the drain. It means in case voltage divider will happen, approximate according to the voltage divider 3 or 4 or 1, whatever it may be, that voltage should come to the drain. But here we are getting 19.5 volts, correct? That should be here then. 19.5 volts. Then what about source? Source also 19.5 volts, correct? That's directly supply. From supply only it's coming. See, the main problem is here because the gate has voltage, correct? If gate has voltage, it should be separate. Means here drain also 19.5 and source also 19.5. Something malfunctioning is occurring here, correct? It should not be equal. One is voltage divider should happen, otherwise means approximate 17 or 18 should be there in drain, but as per the source only we are getting. In this case, in a cold test only we need to check all the component. Okay, all the component first preference goes to, first you need to check the schematic one by one. All the production IC logic will be there, no, that circuit. In cold test only you need to check. Cold test in the sense you need to check using the beep sound. Okay, now I had some doubt, correct? What is that? Here source also same and drain also same. Why? It should not be, correct? In this case, this MOSFET, see, almost beep. It should not happen. In a cold test I am checking, I am not giving the supply. In cold test only it's happening. Okay, see, the gate is good, gate to source and gate to drain is good, but source and drain has some issues. What is that issues? That you need to check. It's left on you, because the fault finding I showed you. After that, how to solve it? By seeing the schematic, you can check one by one. Okay, if you really want that video, definitely I'll do that. But the thing is, our intention is not doing the video, but the thing is main how to do the fault finding. Clear? That's it. In shorts, I will show you the display if it rectified. Okay, thank you very much.